Section 4, the state of the working fluid. We know when system is in equilibrium state, there are 6 state parameters: P, V, T, U, S, H is 6 parameters. However, when we have a research deeply for the 6 parameters, we can find in these 6 parameters, only 2 of them is independent. Others can be expressed by these 2 parameters. Their relationships are called state functions. For example, ideal gas function PV equals RT is very old the state function. Another some very typical function is van der Waals function. P and A over V power second times V minus B equals RT. So this function, we can use them to describe the relationship between the state parameters. We know only 2 independent properties parameters are necessary to define completely the state of the fluid. Under equilibrium state, we can use a plane coordinate system to represent the state. For example, we can use P and V to build a coordinate. We can use the T and S to build a coordinate system. In the system, if the system there is some change, certainly some change is very special, different change with different characteristics. One change is very typical is reversible change process. So here we discuss reversibility. The state of a fluid can be represented by a point located on a diagram using 2 properties as coordinates. When a system changes the state in such a way that at any instant during the process, the state point can be located on the diagram, then the process is called, can we think it is reversible. Just to say, if the process is reversible process, we can draw a line to describe the process in a diagram, in a coordinate. For example, PV diagram, TS diagram. If the process is reversible, we can use a line to describe this process. Criteria of reversibility are as follows. There is some criteria. The first one is the process must be frictionless, no internal friction and no mechanical friction. The second, the difference in the pressure between the fluid and its surroundings during the process must be infinitely small. It's very small. Just to say, this process takes place very slow, very slow. The three, the difference in temperature between the fluid and its surroundings during the process must be infinitely small. Just to say, the criteria of reversibility, certainly there is no friction. Also, P and the temperature, there is no very big difference with the temperature, with the surroundings. No so big the difference with the surroundings. Okay, thank you.